Hi everyone, we are Group 9. Today, our research topic is ImageNet, a large-scale hierarchical image database. In modern time, the amount of the data stored in electronic machine is increasing every year, which makes some data-driven artificial intelligence application possible. But a reliable and stable computer vision application require high quality and a huge amount of data to support. Because any machine learning model require high quality data to train. So what is the ImageNet? The ImageNet project is a large visual database designed for use in visual object recognition software research. More than 14 million images have been hand annotated by project to indicate what objects are pictured and the detailed classification of each object in image.
So to start with why ImageNet is so special, we want to compare with 4 different image dataset, which is also compared. So there's a tiny image dataset, label me dataset, ESP dataset, and L-Hill dataset. And for the feature that we want to compare, the first one is label disam, which means offering disambiguated labels, clear labels. And the second is clean annotation. Third is dense hierarchy, and fourth is full resolution. Fourth is publicly available. Fifth is providing segmentation. So ImageNet, except providing segmentation, does well on every aspect of what needs to be done for image data set, while others have some lacking behind within those features. So the structure of ImageNet is quite interesting. So the structure of ImageNet is based on hierarchy tree of WordNet, which is a tree of English words according to their meaning. So for example, there's a mammal on top of the tree. After then, there's a primitive. After then, there's an ape. After then, there's a gorilla. So each node represents a group of image or a meaning of a image with certain meaning. And each leaf node is subdomain of the root node, as you can see that they are under their root node. And for the accuracy and diversity, the ImageNet gives 12 subtrees, 5,247 synsets, and 3.2 million images. On the left, you can see the camera holder. You can see the various diverse viewpoints from where it was taken and the various backgrounds of it. Also for the bridge images on the right. So you can see that the ImageNet surely is giving a whole lot of diversity in every synset or word that they are providing.
The next, I will talk about the process to build the ImageNet. First step is collect image. The median is the search word in the WordNet onto the search engine. So they get a word and they search it on internet. They get the image of different word. Then they append the query with the word from parents node. Then they translate this word to different language and search it on internet by different language. It ensures the diversity of the image database. The next is to try to clean the image. The main idea is they use Amazon Mechanical Turkey to let people label each image, and they implement an algorithm to dynamically determine the number of words needed for different category of image to be well labeled. So when people see the image, they give a label. They vote for which class it belongs to, then the research group choose the most voted label as the correct label.
So one of the most important aspects was that the ImageNet offers a whole lot of a large scale data set, and it gives clean images. So for example, clean images and labels. So for having a large scale data set, they're comparing MBNN, which is naive Bayesian nearest neighbor model, which is just the regular model, and the MBNN 100, which is same MBNN model, but the number of images per category is limited to 100. We can see from the left graph that the MBNN model outperforms MBNN 100 model because it has more data set and feeded to the model. So you can see that the more data set is gives better performance. For clean data set, they are comparing NN voting plus clean ImageNet with NN voting plus noisy ImageNet. So noisy ImageNet is just the images that they collected but not done through the cleaning process. So if you compare the graph on the left, you can clearly see that the NN voting with clean ImageNet outperforms the model with noisy ImageNet. So we can clearly see the importance of clean images for the image data set. Also, the most important thing is that it has a hierarchical property. So TreeMax classifier has a hierarchical property, while independent classifier does not have hierarchical property in the classifier. As you can see from the graph, the red one with the hierarchical property outperforms those without hierarchical property for every tree height. So we can see that the hierarchical property is very important for the ImageNet.
Then another available application for ImageNet is automatic object localization. Because the large scale, clean, and full resolution hierarchical property of ImageNet allows the model to extract the underlying features such as location of object. So the author of ImageNet randomly select 100 picture and mark the location of the main object in the image. He found, like we see this image, the location is good, and so he think the ImageNet has the potential for researcher to do the non-parametrical mode to automatically analyze the location of object in image.
So the conclusion is first, ImageNet supports a clean set of full resolution images that allows object recognition to be more accurate, especially by exploiting more feature level information. Secondly, ImageNet leverages hierarchical properties of image label that enhances classification performance significantly. Lastly, larger scale image dataset allows models to extract additional information about ImageNet label for entire WordNet synset. Currently, it is only done for 10% of ImageNet. Secondly, they suggested exploring more effective methods to evaluate the Amazon Mechanical Turk user labels to efficiently label those. Lastly, the author suggested including localization information such as outlines and locations that are very important for computer vision research on image segmentation. Thank you very much.
Thank you.